Okay, today we are going to talk about classifying triangles. Most of you have already hit the rest of the playlist. I will be going over, but we're going to start with triangles. We're going to start with classifying triangles. And you classify triangles according to their properties. Properties are facts about them. There's two ways to classify triangles. You can classify them by their side lengths or their angle lengths. And we're going to talk about that. So you should have two papers, okay? The two papers should have this one that says triangles on it, and then you should have this one that's two-sided, and we're only going to deal with is it a triangle. But let's start with the triangles one. And if you notice, it's a foldable. So what you're going to do is you're going to fold it to meet right here in the middle, like this. Okay? And then make it real nice and straight, if you can. And then you're going to bring it over this way and do the same thing. If you notice, this one might overlap just a little because you want to be able to see all the words. Okay? Just like that. Now, and these are the different triangles we're going to talk about. And what it is that you have your side lengths and you have your angle measurements that you can classify triangles. So we are going to talk about side lengths, properties, and angle measurement properties. Okay? So, let's take a look. We have acute, obtuse, and right, and we have equilateral, isosceles, and scalene. We are going to start with our side lengths because those are a little bit easier to look at and see. So we're going to start with that. We are going to start with equilateral. So if we open back up our little foldable here, and we look at our triangles, we have a couple things. It starts with all three sides are congruent. Congruent. And all congruent means is equal. They are all equal. Okay? And what I mean by that is your sides. So you have side AC, okay? Side AC. And if you notice this little line right here, this is for side lengths. This represents the side lengths. So that line is supposed to be there, and it always goes above the two side lengths, the 2 points that connect the side that you're talking about, okay? So in this case, AC is congruent to CB. So AC is congruent to CB. And CB is congruent to BA. So AC is congruent to CB, and CB is congruent to BA. And if you notice, we have these little ticks right here. They're called ticks. And this makes them all the same because they all have one tick. As you notice, however many ticks they have, that means those sides are the same. In this case, they all have one, which makes them all the same. If you also notice, we also have all the same lengths. The same thing, you have one little line. If it was different, it would have two. But all three angles are congruent. Sorry about that, guys. Sorry about that, guys. Okay, so let's get back to this. So, if you notice, all three angles are congruent, and each angle is 60 degrees. And the reason for that, and you will get more into it later, is that you need to understand that a triangle, and if you want to write that right here, a triangle, all the measurements added together equals 180 degrees. So all angle measurements added together equals 180. So 180 divided by 3 is 60. So now how this works when you're dealing with angles. The angle you're talking about is always your middle letter. So it's going to be the two letters around it. Okay? And I'm going to kind of write this underneath. This represents angle. Okay? So we're talking about angle A. And if I wanted the angle A, I need to know I need the letters B, A, C. So angle BAC is congruent, and this is your congruent sign, congruent to, now we're going to do this angle, so it's going to be ACB, angle ACB is congruent, now let's do B, CBA, CBA. So the angle you're talking about is always in the middle. Make sure you don't forget that, okay? So these three angles are congruent to each other. And this is a equilateral triangle. Okay? Now, the next triangle is an isosceles triangle. Isosceles, if we look at it, remember I told you that you'll have the ticks, and the ticks mean that they are the same. So if you notice, both these sides have two ticks, which means that there are two sides are congruent. So these two sides are congruent. So this time we're looking at FD. So side FD is congruent to side DE. So it's congruent to side DE. Alright? And then, if you notice, we also have two angles, okay? So the angles opposite the congruent sides are also congruent. So what that's saying is that this angle is congruent to this side, this angle is congruent to that side. Okay, and we're going to make our angles, so we're talking about F first. So our angle would be EFD. So EFD is congruent to DEF. DEF. So if I want this angle, remember you have to do the letter in front of it and the letter after it. EFD is congruent to DEF. Okay? So that's an isosceles. So far we've talked about an equilateral triangle that has three sides and three angles that are the same, congruent. And then we also have an isosceles triangle that has two sides, two angles that are the same. And then our last side length one is a scaling triangle. And if you notice, they all have different different ticks. You have 1, 2, and 3, which means that none of these are congruent. So there are 0 sides congruent and 0 angles that are congruent. So nothing's congruent on here. Everything is different. If you look, you have 1 here, you have 2 here, and you have 3 here, which means that none of the sides are the same. So if you need to write that down, that no sides are the same. To help you remember that a scaling triangle means there are no sides that are the same. Okay, and no angles either. Alright, so now let's move over to our other side. So if you want to fold this, you can. This is your side length. If you want to leave it open, you can also. So now we're going to talk about properties classifying angle measurements. And you have 3 of these. You have acute, obtuse, and right. And these are all dealing with the angles, okay? So we're going to be looking at angles here to determine what kind of triangle it is. So if you open it up, if you look here, if you notice that all of these angles add up to 180, but there's something that's very important about each one of them. Each angle, so every angle in this triangle is less than 90 degrees. So each angle, see 87, 38, 55, all of these angles are less than 90 degrees. Okay, so an acute angle, and if you want to write this on the front, is less than 90 degrees. So acute angle is less than 90 degrees. Okay, so if you open it back up, let's look at the next one. Well, this time, if you notice, we have 2 that are less than 90, but we also have 1 that is more than 90. So here, you're going to have one angle is greater than 90 degrees. So for obtuse, you have only one angle, only one that is greater than 90 degrees. So if you want to put one angle greater than 90 degrees. So one angle is greater than 90 degrees. Okay, so we have acute, that's less than 90, obtuse, that's greater than 90, and then last, you have a right angle. And I know a lot of you have seen this already. In a right angle, if you notice, it's one angle is 90 degrees. So every time you will have this little guy right here. Sometimes they won't show you the actual 90, they'll just put the box. But if that little box is there, then it means it's 90 degrees. Okay, so a right angle is one angle 90 degrees. So acute is less than 90, obtuse is one angle is greater than 90, and right is one angle is 90. Okay, so that actually is all of our classifying triangles. It's pretty simple. These will be ones that you need to know from now until you graduate. You'll actually get into further detail when you get into higher level math. So make sure you don't forget this. This might be something you want to keep in the future. That would be great. But now we're going to move on to the next paper, and I'm going to kind of work through that one kind of fast because I don't want to run out of time. So if you look at the next paper, we have, is it a triangle? Okay, well, we talked about being able to recognize them and classifying them, which we can do by their angles and we can do by their sides. But here, we can actually do it just when we're given numbers, or we're also going to talk about finding the missing angle. So let's start with, is it a triangle? And the main rule for is it a triangle, just so you know, is taking two of the sides, okay? So if two of the sides are the two smaller sides, that's very important, the two smaller sides added, okay, so added together, must be greater than the third, okay? And all this is saying is that side A plus side B is greater than C. Okay, that's all that is saying. But, for example, if I were to give you 3, 10, and 11, okay, 3, 10, and 11. So it says the smaller sides added. Well, what are our smaller sides? Our smaller sides are 3 and 10. So 3 plus 10, okay, is greater than, well, greater than, there's our greater than symbol, 11. Okay, well, let's see. 10 plus 3 is 13. Is 13 greater than 11? Yes. So this is a triangle. Okay. Another way, not another way, I'm sorry, but just sometimes you won't be given the actual triangle with the sides. You'll just be given numbers like this. 5, 2, 9. Okay. So you'll just be given 3 side lengths, and it'll say, is it a triangle? So you say, okay, well, I know this rule. That rule is we take the two smaller sides, so 5 plus 2, and we see if it's greater than 9, which is our third side. So 5 plus 2 is 7. Ooh, a 7 is not greater than 9, so this is not a triangle. And if you want to write that down, you can. Not a triangle. Okay? So that's how you do rule 1. Now, the other rule, which you won't really see very much, but you kind of need to know it for future, but how this works is that the smallest side across, okay, and sorry, this is a misprint. So it's the smallest side across the smallest angle. Okay, the smallest side across the smallest angle, and the biggest side is across the biggest angle. So how that works is if I have 40 degrees here, 60 degrees here, and 80 degrees here. Well, my smallest angle is right here, and so my smallest side will be there. My biggest angle is here, which is 80, so my biggest side will be there. So that's another way to see if it's a triangle. So just making sure that the smallest side's across the smallest angle and the biggest side's across the biggest angle. Pretty simple. All right, last two things. One we've already discussed, but one I'm going to tell you here. A straight line equals 180 degrees, and then a triangle, which we talked about this earlier, all angles added equal 180. So all the angles added equal 180, and that's very important so when we start working with finding the missing angle. So we know that we're going to add all of our angles up, and it's always going to be equal to 180 because a triangle always equals 180. So for example, right here, I always start with x because we don't know what x is. So x plus 45 plus 30, okay, because all angles added, here's all my angles added, and all of them equal 180, okay? So here, what we would do is we combine. We can only combine those because we can't combine x's with numbers. You can only combine numbers with numbers and x's with x's. So 45 plus 30 is 75. So now we have x plus 75 equals 180. Well, now we have an equation, and from what we know, when we're solving an equation, we do the inverse operation, which is the opposite operation, which is adding. So opposite of adding is subtracting. So we're going to subtract 75 to both sides. This cancels, so now we know that x equals 105 degrees. And you can always check your work by plugging that in. 105 plus 45.
Sean Course.
Sorry about that, guys. Plus 30 equals 180. So 105 plus 45 plus 30 equals 180. So our answer would be correct. Okay? So I'm going to do one more example for you, and then the rest is on your own. I'm sorry, but I think you got it. So let's look at this one. Remember I told you sometimes they'll give you the box, but they won't tell you what the degrees is. The little box always means 90 degrees. So we have x plus 90 plus 30 equals 180. Combine these two, so we have x plus 120 equals 180. Remember, inverse operation, subtract 120 to both sides. That cancels. X equals 60 degrees. So now we have this is 60. Now, funny thing, this is what? A 90-degree angle, so this is a right triangle. Now, what is this? Well, if you look, this is 105 degrees, and from what we learned, when we have one angle that's more than 90, that is an obtuse angle, or obtuse triangle. So you can write that. So that's the ways of finding out if it's a triangle, finding the missing angle, and classifying our triangles. I hope this helps you. I would definitely practice before you take your content assessment, and I wish you luck.